Hello and welcome back to another assessment preparation video. So let's go ahead and take a look here at 1D for Math 154, 1D, where we're going to be talking about using Euler diagrams, Euler diagrams to talk about whether an argument is valid or invalid in a little bit, which is a special form of a Venn diagram. But let's get this here. Write the word or phrase that best completes each statement or answers the question. Decide whether the argument is inductive or deductive first. His last 4 bats were strikeouts, therefore the next one will be a strikeout. That's an inductive. It is taking a little bit of information that already exists and trying to conclude something that is a bigger conclusion from something that doesn't exist, right? And so that's not deductive, that's inductive. Fresh fruit is expensive in the winter. This is January. So these fresh strawberries will be expensive. That's deductive because January is in the winter. So all fresh fruit is expensive in the winter. It's winter and fresh strawberries are fresh fruit. Therefore, they are going to be expensive. Every coach must know his sport. Steve Superior is a football coach. So Steve Superior knows football well. That would be deductive, right? All coaches know their sport well. Steve Spurrier is a football coach. Steve Spurrier must know football, which is his sport, well. This is an inductive argument. They added several prime numbers together and saw that they got an even number. This is inductive. It's also not true, but this is not asking you about true or false. It's just asking you, is the reasoning deductive or inductive? Don't forget that 2 is also a prime number. So I could have added 2 plus 7 and I'd be adding 2 prime numbers and I'd have gotten 9. So too little information here led you to a wrong conclusion, right? Practice makes perfect. Therefore, if I practice, I'll be perfect. That is a that's deductive. Just 1 second here. Yes, that's deductive. So you start off with a big statement about, practice always makes perfect. If I practice, I'll be perfect. So that's deductive because you start off with a big statement, say, if I do that thing, then I'll get the consequence. That's a deductive argument. All US presidents have come from the contiguous 48 states. No person from Alaska can be president. That's inductive. Just because it hasn't happened yet doesn't mean it can't happen. It's an inductive argument. For any positive number p, the absolute value of negative p is equal to p. Therefore, the absolute value of negative 94 is equal to 94. That's a deductive argument. Starting off with a big, always true rule. This is a specific case of it. Therefore, that should also follow the rule. All right. Determine the truth of the premises, discuss the strength of the argument, and assess the truth of the conclusion. So Monday is one of the days of the week. Thursday is one of the days of the week. Saturday is one of the days of the week. All of the days of the week have names that end in day. All right. The argument is weak, though it's true. It comes to a true conclusion, but you have only listed 3 days of the week and made an inductive argument. It would be much better for you to list all 7 days of the week and say the list of all of the days of the week are Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. All of these days of the week end in day, day. therefore all the days of the week have names that end in day, right? Something like that. So it is a all the premises are true, the conclusion is true, the argument is weak, but the conclusion is true. So Calvin Coolidge was over 35 years old when he became president of the United States. Bill Clinton was over 35 years when he became president of the United States. Ronald Reagan was over 35 years old when he became president of the United States. Every United States politician is at least 35 years old. Okay, so premises are true. That's actually required by the US Constitution, if you did not know that. That's why all of them were 35 years old or older when they became president of the United States. But that doesn't have anything to do with any other position of a politician, governor of a state, or a representative or senator of a state at the federal level, or school board members are technically politicians in a sense too. They run for a political, assignment. They run on a ballot. So no, this is an invalid conclusion. The premises are all true. The conclusion is false, and the argument is very weak because you're trying to say something about all politicians from just 3 presidents of the United States. And those are all politicians all around the world too. So baseball, football, basketball, golf, and hockey and tennis are all played with a ball. Conclusion, all sports are played with a ball. True premise, no. False premise, hockey is not played with a ball, it's played with a puck. All sports are played with a ball, not true. We just said that hockey breaks that rule, right? So both the premise and the conclusion are false there. Strength of the argument is very weak. I'm sure we can think of other sports that are played without a ball, like swimming, or wrestling or something like that, right? Premise, 8 plus 11 is 19, that's true. 12 plus 7 is 19, that's true. 38 plus 33, 71, that's true. Whenever we add an even number to an odd number, the result is an odd number. True, but it's a weak argument because we have not generalized this. There's a way to generalize what an even number looks like and what an odd number looks like. And you would not typically do that in this class, but I'm going to show it to you. If this confuses you, that's okay. Not required for your test. But I'm going to say 2 times a number is an even number. And 2 times a different number plus 1 is an odd number. And M and N are integers. Okay, so if I want to generally prove what an even plus an odd is, let's take 2n plus 2m plus 1, and that's going to be 2n plus 2m plus 1. I'm going to group these 2 parts together and pull the 2 out. N plus m plus 1. N plus m is a different integer. I'll call it p. Okay, so let's call this 2p plus 1, and this is going to be an odd number. Number. Okay, so is, and maybe not even a different integer, but let's just say is another integer. Let's write this in a different way here. P, which equals n plus m, is also an integer. And I know it's an integer because an integer plus an integer is always an integer. That's called closure. That's, again, that's kind of way above this class to think about closure and things like that. But I know that you intuitively know that when I add an integer to an integer, I always get an integer. I'm not going to get a fraction. I'm not going to get a decimal. I'm not going to get a square root. You know, I'm not going to get something crazy, right? That you know that when I add positive numbers and negative numbers together, I always get a number that is a negative whole number or 0 or positive whole number. Those are my only 3 options for that. You've known that for a long time. So there you go. There's the proof of it if you were interested in that. So the conclusion is true. The argument's not really that strong because we did not generalize the premises here. All right, premise, I get lower grades than my best friend in math, chemistry, and English. Conclusion, my friend is smarter than I am. So this is, I mean, it's kind of hard for me to evaluate the truth of the premise. I'm going to assume that the person is telling the truth here, assuming that they are telling the truth. There's probably a strong argument to be made there that the friend is smarter. It's not a 100% for sure thing. Why not? Because one second here. Because maybe you're smart in other things than your friend is. There's different types of intelligence. That's one reason why I could definitely say that. Just because your friend gets good grades in math and chemistry and English doesn't mean that they're going to get good grades in history and social or you know, things that are economics or art class or whatever. But yeah, there's no way to determine the truth of the premise. The argument is weak. Perhaps the friend studies harder. Perhaps the friend cheats. I didn't want to say that one, but that's a possibility that your teacher put in her answers. So just because someone gets good grades doesn't make them smarter. Or perhaps, you know, I get higher grades in other things, like they said here, biology, history, art. Just like I was saying, academic smarts are not the only measure of intelligence. Like I was saying, since the example is fictitious, there's no way to assess the truth of the conclusion. So you know, you could better measure this with IQ scores, but still that wouldn't tell you every type of intelligence that's out there. But IQ stands for intelligence quotient, and it tries to measure your aptitude, your intelligence over a vast number of different areas in a standardized test that lets you compare two people to each other. All right, draw a Venn diagram to determine if the argument is valid. Here we go. This is where these are actually going to be Euler diagrams that I'm drawing. So all clowns wear makeup. So here's things that wear makeup. Here's clowns. Bozo is a clown, so here's Bozo in here. Bozo wears makeup, valid, because all clowns are in the set of things that wear makeup. Bozo is in the clown circle, therefore Bozo is in the things that wear makeup circle. All lawyers wear suits. So there's suits, there's lawyers. Jack wears a suit. Well, he could be a lawyer or could not be a lawyer. Here's Jack on the line, right? Jack could be somebody who wears a suit who's not a lawyer, like a teacher, if teachers, you know, wear suits, professors, or a CEO of a business or something like that. So no, that does not, just because Jack wears a suit does not mean that Jack is a lawyer. That's an invalid argument. All snakes have fangs. So here's things with fangs. Here's snakes. Terry's pet does not have fangs. So here's Terry's pet. Conclusion, Terry's pet is not a snake. That's valid. To say that because all snakes have fangs and Terry's pet does not have fangs, Terry's pet cannot be a snake. That's a valid argument. No surfers speak French. So here's French speakers. And here's surfers. Okay. Pierre speaks French. So here's Pierre. Conclusion, Pierre is not a surfer. Valid. Right? So, all right. Identify the type of argument and determine the validity with a Venn diagram. So, all right, if you are hot, then you'll sweat. James is hot. Therefore, James will sweat. James is hot. Therefore, James will sweat. That is a deductive argument that is looks like this. So if you are hot, then you will sweat. Sweat. Hot. James is hot. Therefore, James will sweat. It looks like that. So this is called affirming the hypothesis, this structure. I was looking for that name because I call it something else from Latin that you don't call it in your class. Affirming the hypothesis. Okay. So that's what it's called in your notes and in your book. Moving on, that was 17. Let's go on to 18. If you break curfew, then you will be punished. Thelma was punished. So here's people who are punished. There's people who break curfew. And here's Thelma. I don't know if she's getting punished because she broke curfew or for some other reason. I just know that she was punished. So this is invalid. This is a this is the form of the argument here. So that is called a converse error. Okay. Your book calls this affirming the conclusion. And that's bad. Don't do that. It's an invalid argument. All right. If you try hard, then you will succeed. Try hard, succeed. You do not try hard, you will not succeed. Well, if I didn't try hard, I could be inside here or outside there. This is invalid. It says, if you try hard, then you will succeed. You do not try hard, therefore you will not succeed. This is called an inverse error. And I assume they call this denying the hypothesis. Yes, they call this denying the hypothesis. And it is also an error. It's invalid. All right, moving on. If you cut me, I'll bleed. So I bleed. Cut me. I do not bleed. So or somewhere out here, therefore you did not cut me. Okay, if you cut me, I will bleed. I do not bleed, therefore you did not cut me. This is called, the fancy name for this is called the contrapositive. This is valid. And you're going to probably call this denying the conclusion. Yes, that is what they call it, and it's a valid argument. All right. If I take a shower, I use soap. Here's use soap. Take a shower. If I use soap, my skin becomes dry. So skin becomes dry. There could be other reasons your becomes dry. There could be other reasons your skin becomes dry, but if you use soap, your skin will become dry. If I take a shower, my skin becomes dry. That's valid. That's let's just call this P, Q, and R for a second. Is take a shower. This is use soap. This is skin becomes dry. So this is, if I take a shower, then I use soap. If I use soap, my skin becomes dry. Therefore, if I take a shower, my skin becomes dry. This is called transitive property. I think I spelled that right. And so that is a valid argument. Okay. Gotta go back and reprint some pages here. That's okay. If the moon is made of cheese, then what goes up must come down. Now this is just a silly argument because we know the moon is not made of cheese, but let's say P equals the moon is made of cheese. We're not trying to assess the truthfulness of these things. We're just saying test the validity of the argument. Q is going to be what goes up must come down. R is Americans like apple pie. Conclusion is going to be, therefore, hang on, I haven't written the argument out here. P implies Q. Q implies R. Therefore, P implies R. For the same reason as before, this would be valid. It has nothing to do with if it's true or not true. Just that's valid. That if the moon is made of green cheese, according to this set of premises that we assume are true, then Americans like apple pie. Premise, if you loved me, then you would buy me a new car. So if you loved me, you would buy me a new car. If you wanted me to be happy, just something completely different than loved me. If you wanted me to be happy, then you would buy me a new car, right? Conclusion, if you loved me, then you would want me to be happy. Let's write it out symbolically like that, and you're going to see this makes no sense at all. This is invalid. Right? There's no way that I can get from P to R. They're not related to each other at all. So not directly. And if this was the other way around, and I said, if you buy me a new car, then you want me to be happy, then I could go from P to Q and through Q to get to R, but that's not what I did here. So this is an invalid argument. Okay, last one for this video. If I pay my bills on time, then my credit will be good. If I pay my bills on time, then my credit will be good. If my credit is good, then I will become a movie star. Therefore, if I pay my bills on time, then I will become a movie star. Well, that's valid. It may not be true, but it's valid, right? That is, I can go from P to Q and get from Q to R. P knocks this domino over Q, and Q knocks that domino over R, and that is the transitive property. It is a valid logic chain. All right, so just show you guys those that valid, valid, invalid, valid, right? And there's your answers are at the end, but this is your work that you would need to support some of those answers where the work wasn't shown. All right, I will have another video up here in not too long for 1E, and hope you all doing well with your semester. Hang in there and pay attention to this unit. This unit is foundational to everything that you're doing this semester, because you're doing quantitative reasoning, and the reasoning part of it has to do with this logic. And does what you're doing actually make sense? And does your answer make sense? That's why we're spending all this time doing this in Unit 1. See you guys next time.